Alright, here's the second chi-squared that I'm going to do with some M&Ms. So, first I'll give you the data. We got orange M&Ms that has 15. We got the blue M&Ms, I counted 9. The green M&Ms, I had 11. The brown M&Ms, so I'll call this BR and that BL, is 3. And the yellow M&Ms was 6. And the red M&Ms is 10, which gave me a grand total of 54. Now, in the percentages that they were giving, they told me that orange was 20, that blue was 24, that green was 16, these were both 13, and good old yellow was 14%. So these are all the percentages. And just to be sure, that totaled up to be 100%. So, let's quickly do the expected values. So when I multiply them, so that we can get this all out of the way, and I don't need a total category anymore. So, when I multiplied 15 times 0.2, I mean when I multiplied 54 times 0.2, this turned out to be 10.8. This turned out to be 12.96. This turned out to be 8.64. 7.02. The yellow was 7.56 and 7.02. I would put all of the numbers for this one into L1 in that order, and I would put all of the second numbers into L2, so that when we have to do the calculations, we don't have to do it one by one, and we can just do it all at once, and it saves time. And there will also be an added bonus towards the end. So, we are looking at the proportion of colors in a bag of M&Ms. So my initial hypothesis is probability of brown equals 0.13, probability of red equals 0.13, probability of yellow equals 0.14, the probability of green equals 0.16, the probability of orange equals 0.2, and the probability of blue equals 0.24. The alternate hypotheses, at least one of those is incorrect. And 8's of not. Conditions. We got an SRS, independence, more than 540 total M&Ms in the world, and expected counts are greater than 5. Sounds good. Calculations. The summation of, and of course we are doing a chi-squared goodness of fit test. Which I should have put back over here. Chi-squared GOF alpha equals 5%. Always want to name what we're doing. So we're going to do the summation of the expected, scratch that, the observed minus the expected squared divided by the expected. So in our case, we're going to make L3 equal to L1 minus L2 squared divided by L2. And then after we do that and we hit enter, we're going to sum L3 and get our answer, which was 7.38. So, since chi-squared, it's nice we always do bigger than. Now, of course, I need to say how many degrees of freedom I have. Since there were 6 colors, I'm going to do 5 degrees of freedom. And I'm going to do my chi-squared CDF to get an answer of 0.195, which evidently is bigger than 0.05. So what are we doing? We fail to reject the null hypothesis. I do not have reason to suggest, that's the second time, evidence to suggest that M&Ms have changed their proportions of colors. Now, I said we could have a special little technology at the end. So, when you go to stat, and then you go over to tests, where all our great hypothesis tests are, we can go down to letter D, which says the chi-squared GOF test. And observed, we put down L1, and expected, we put down L2. For degrees of freedom, we have 5, and you can calculate or draw, whatever your preference. When I put calculate, it tells me that chi-squared equals 7.37, so on and so forth, and it tells me that P equals 0.194, which once again shows you that Mr. Fruit Loop actually does know what he's doing, or he programmed the calculator to do what he wanted it to do. And that is all for now.